So we want to continue with differentiation from first principle. Remember from the last lesson I shared, we have that our dy over dx equals to the gradient of the line tangent to the curve. And so we say that only happens when the change in x in this approaches what? Approaches 0. Approaches 0. So that is what we have. And we have that this is going to be x plus change in x minus f of x over dx. You can attach a number to that and say x1 as the case may be. But that is just the general equation for what? For this first principle. And let's say, for instance, we want to determine the derivative of f of x equals to x. What will be our derivative? Let's go with this formula. So our dy over dx will be equals to the limit as dx, as change in x goes to 0, of this is supposed to be, there's supposed to be a limit here as the x approaches 0. All right, so that's what we will have. And then this will be our f of this will now become x plus change in x minus x over change in x. From here, you will have the limit as dx goes to 0, and this will be change in x over change in x. And clearly, you can see that if you don't have to apply the limit here, you just know that this will go to 1. All right, that will be 1 already. Our dy over dx is 1. What if we have our fx to be equals to x squared? So the function, the dependent variable, is equals to x squared. What are we going to do? Same thing we've done there. We know that this our dy over dx will be equals to lim change in x as it approaches 0, and that will be x plus change in x squared minus x squared. That's what we are going to have divided by change in x. If you expand this, this will be lim as change in x approaches 0. If you expand, this will be x squared plus 2x change in x. Let me give it more space. This is going to be limit as change in x approaches 0 of x squared plus 2x change in x plus change in x all squared minus f squared all over change in x. From what we have now, our limits as change in x goes to 0, this will cancel this, so we are left with 2x change in x plus change in x all squared over change in x. So that will be equals to, that implies our limit of change in x as it approaches 0, and then this will be, if we factor out change in x, we have 2x plus change in x over change in x. This cancel this. So our dy will be when we take the limit. If this is 0, this is going to be 2x. By the time we take this limit, this will be 2x plus 0, and our dy over dx equals to what? Equals to 2x. That is what you are going to get. Now, I want to, from this, by the time we do for x raised power 3, we will discover that our answer there will be 3x squared. From this pattern, we can deduce that for any function f of x, which is equals to x raised power n, our dy over dx, differentiation with respect to this, the derivative of this will be equals to n multiplied by x n minus 1. This is called the power rule. It works, for this simple quadratic expression, polynomial, and the rest. This actually works easily. All right, so this is the generalization of what we have shown from the first principle. First principle is also applied to get the product rule, the quotient rule, the function of function, and the likes. All right.